I bet you all enjoyed the lunch. If not, I'm sorry that. But two guys, one David Pech and one Petr Rais, came you to present, really present the feel, the breeze. So there are first rows and they are empty. So everybody like to take care of their health and don't like to freeze, I bet. So yeah, from my side it's all and stage is yours.
Hello. So we are very glad that you made some time after the lunch, to be educated, of course. And we also thought like how to approach this session because we were going to talk about some sustainability topics. So I am David. This is Petr.
Hello.
And we would like to discuss how did you get here, right?
Yeah.
So the thing is that depending on the level, let's say, of altitude of your transportation, you can get a very different experience and number of kilograms of dioxide that you produced. So what I would like to highlight that if there is anyone who use a plane, this is the worst thing that you can do from Bratislava for sure, right? Even though the time probably is not that bad, but still. You could have taken a bus, but from Brno, typically, I guess that from Bratislava is not that convenient, so we are comparing slightly pears to apples, right? Or, in my case, I took a train from Ostrava, which is, as you can see, quite green. Perfect, right? Maybe you are just a Prague person, so you took a subway, why not? Or you could have walked. Is there anyone walking from Bratislava to Prague over here? No? Surprisingly. Okay. I really wondered why there is 0 kilograms for this one. And the thing is that, for basically animals, humans, it's not measured. So there is not, let's say 0 exhales, but it's not measured. In fact, when I discussed it with Claude, he said something like, okay, but if you are to walk about 330 kilometers, you would consume the food an equivalent for 20 kilograms of exhales. So, if you need to digest anything, basically this would add up. But the walking itself is completely fine. You are some kind of exemption, right? But let's get maybe to something more technical, and this is what the talk is going to be about. If you are running some pod that is idle and that is consuming 5 watts for a year's consumption, you could get also to these numbers, meaning of one single trip around, Prague. Which is kind of frightening, meaning that if you imagine this and if you really try to untangle it from there, this means basically that if we would save a few pods in each of our clusters, we might significantly save, right? So it's not just about the money perspective, it's also about being green. One thing that I will remind you again later on is that how the calculation is being done. So of course, if you are using a bus, an airplane, etc., the calculation is quite obvious. You just take the fuel, right? And it's some emission factor. But if you are using electricity, it's very different. So for each basically state or region, there is some coefficient that basically says, okay, for the Czech Republic, you get some number. So you can basically do some sort of estimation and some calculation how much of the consumption is being equivalent to how many exhaust gases. Thank you. So just a reminder why this is important, right? We have an example of Meta basically needed to cancel its plans to have another data center in the Netherlands. The motivation for it was that, in my company, we also had a Netherlands data center. And when we wanted to expand it, a year from there, we don't have it there anymore because we are not allowed to get more power for some reasons. And this is just an example how demanding that data center is. So, it's really a huge investment that probably can correlate to some car, automotive factory, etc. So a lot of land also involved. You can see some politicians discussing it in Netherlands and having some motions against it. So it's really not obvious if we will be able to build these data centers, maybe in the same way that we have been trying to build some power plants lately, and some people are opposing it. So something like this is definitely going to be a problem, and we cannot take that, some large company is going to build yet another data center as a granted thing, right? So what we are trying here to present or address. First thing is that we, of course, are Kubernetes people, right? So we would like to highlight that there are some distributions that can be significantly smaller that you can get by the default Kubernetes setup, having Freenode on the master, etcd, and like all the jazz. For example, there is K0s. This is the pronunciation that hopefully is correct in my, in my mouth. So you don't have an etcd, you, for example, have SQLite behind the scenes as a database, you have just a single node cluster. So even for a very small environment, this is the way how you can have Kubernetes on there, and from Kubernetes you can have Argo CD and a lot of stuff behind it, right? So here is some explanation that even on Raspberry Pis, you can run it. For this presentation, we've tried to do also Raspberry version 3, but unfortunately like 1 gigabyte of memory, that was enough, but the speed of the SSD, sorry, not SSD, but the flash drive was too low, so we needed to switch. So probably this is, let's say, some practical example if you are doing like some kernel stuff, optimizations over there, that with Raspberry Pis, you can run the Linux pretty effectively. You can run K0s as a distribution on top of it, and you basically have just a regular operation system, not a big deal, right? Very similar to what you have on your regular servers, which I think is very different because typically when we are discussing some edge cases and IoT things, the operation system, the distributions you get is super limited. But you can see with this that it really resembles a regular computer, not a big deal. For the installation, we will showcase it later on, but you have some very simple script how to do it. You just connect it to internet and let all the files being downloaded if you like. So this is definitely a way how you can build, of course, your home lab, but of course, this is extendable to some factory design. Imagine that if you are in a scenario, if the company would like to have some, let's say, detached offices, etc., and they are deciding if they need to buy a rack there with a regular one-use server, or maybe we can go with something lighter. So this is really your chance to get Kubernetes, there, but also something lighter from the sustainability perspective. One trick that you might use is that Argo CD, in fact, does not need to cover just the cluster it is installed in run. So basically, you can control through the Argo CD and use it as some kind of a control plane to other clusters. And this is basically the example that we have over here. So the Argo CD is running on the cluster on the machine, and on the Raspberry Pi, there is just the Kubernetes control plane through K0s, and Argo CD syncs to it. Again, we will showcase on the demonstration. There is just one parameter, so you can have multiple clusters being configured in Argo CD settings, and basically the sync works, over the network as it would work locally, out of the box, not a big deal, right? What is also interesting that there is a primitive in Argo CD like CRD that is called application sets. Not sure if you are familiar, but basically you can have some multiplication, meaning that you say, okay, for these 5 hosts or clusters in our case, these 5 Raspberry Pis, I would like to have all the same versions, of these manifests. And it's very easy then to control, 10 devices instead of 2. You don't need to do anything manually, you just work with the application set. It can also have a connection to Git, if you like. A lot of cool things over there. But the main idea is that basically you have a central, we call it HQ, like the headquarters cluster, and then you sync to the edge location from over there. Again, we are not showcasing like anything edge specific. We are really having a regular, let's say, operation system and things around it. What I would like to highlight is that people typically think that, Argo CD, for example, for it's to work properly, it needs to be always online, connected, etc. It's really not so, right? So Kubernetes itself has a lot of checks and balances, let's call it like this, that it can recover from pod restart, pod failure, It can scale back some deployment if you have some problems. So a lot of scenarios can be covered just by the Kubernetes itself, and you don't need Argo CD there. So just like a reminder that even if you have some location that, for example, keeps switching on and off, that has unstable internet connection or anything in this direction, you still can control it remotely. Of course, there might be some gaps in your logging, for example, in your metrics, but do you really care if we are in that detached office, home lab scenario? Typically you don't. So the scalability and the ease of management is definitely something that you can leverage out of this example. One CNCF project that we would like to highlight over here is the Project Kepler. Is there anyone that has already used it? No? Okay, perfect, there are people over there. So, you know, it wouldn't be a CNCF project if there would not be eBPF, like somewhere in behind, but not really. What does it do? Basically, it is trying to calculate and bring the power consumption to the units that we know, and we can work with them on our company level. What do I mean by it? It basically says, on this node, we have this input power, we have this consumption, CPUs are distributed across running pods like this. So it is trying to calculate idle power and the dynamic power, it calls it, meaning that you are able to get the numbers, how much power consumption is your namespace X using. So, of course, this is some estimation. The estimation is mostly based on some ratios between the CPU usages. So if it also tries to bundle in the memory, drives, and a lot of other stuff, because even if the server is idle, it is consuming something. There is a table for the comparison, so you can see what is the idle consumption, what could be the consumption in load for different types of hardware. Because we think that people typically as we are getting detached from the hardware, people typically don't know. So this is why we have also the live example over here and some questions, of course, around it later on. So basically, the Project Kepler can give you some introspection, some metrics around these. They may be too complicated, but the baseline is that you can measure the consumption on the namespace level, the very same as, for example, you would measure the number of CPUs and other basic stuff. The project is currently in the sandbox, if I'm not mistaken. And of course, one very interesting thing that is added recently is the GPU power consumption, which is of course going to be huge. As you can see, those GPUs probably will be significantly or several times more consuming than the entire else of your PC. There are several machines that we wanted to showcase, if we may. Thank you. So those are the better GPUs, but they are not for gaming these days. They are for the AI inference and AI training. So these are called accelerators. And just to showcase everything, I don't understand these numbers much technically, to be honest. Let's call it a supercomputer, on a chip, something like this. And the loads that there are really frightening. Something like this basically could maybe heat your small house or a cabin if you'll have something like this, but we are getting in even higher, right? So this is more modern stuff, 1000 watts, right? Why not? And of course, if one of those cards is not enough, then you can bundle them. In this case, you can buy one box that contains 8 of those. It's of course quite expensive. You can see that it is 6 huge cases, and I think it's only one half of it. I have never seen it, to be honest, in a server room. And just one is 5 times the typical rack consumption. So if you imagine, having just the power consumption, the cabling for this, it's something very different to what we are used in our traditional server rooms. Of course, the heating is a problem. Again, very different to what we have with the traditional servers. But you can maybe do the training on one of these and not on your servers, right? So there is also a CNCF effort that is called environmental sustainability, and this is something that would like to further introduce some concepts that we should go greener. There is also some term cons there that is called green ops, because there are not that many ops terms, you know. So if you would like also to measure these consumptions, you can check out the talk over there. But the basic idea is that instead of like counting CPUs, token these days, etc., you can also factor in the power consumption, and you can have it as some like key decision, not just like how much are you going to consume, but for example, if your data center will allow to consume more in the future, if there is still some gap for you in that country, region, etc. They have some meetings, so if you're interested, definitely join them. I think that except for Project Kepler, they have still several like other interesting trades and topics that are appealing. And now finally, we have a demonstration, right?
Right. So we prepared a small demonstration, and of course, if you want to go green, you buy something like solar panels or windmill, and if the sun is shining, the solar panel is producing the electrical energy, and everything can be running. But if there is winter, the weather is cloudy, the solar panels do not produce enough energy, so we have to take the energy from the power plants, from the coal power plants or other kind of power plants, which is not so green. And you don't want to take too much energy from the power plants, and so you want to scale the devices or the nodes or the servers that are not necessary for the regular traffic. So to demonstrate it, I will explain what is the setup. Here we have the solar panel, which is connected to the USB tester via the USB tester to the power bank. The USB tester is giving us the number of watts or the energy that the solar panel is producing. Unfortunately, we do not see the sun right here, so we brought a halogen lamp, which is producing the light for us. Then we have two objects or the two devices, the fan and the LED light that presents the devices that we want to scale if there is cloudy or sunny. If you imagine in the server room, we need to cool the servers. So the fan is our priority, and we don't need to light it or have the light there. We could have the flashlight or something like that. So we will scale down the lights. So as David said, on the main laptop, we have the HQ cluster, which is connected to the Raspberry Pi. And the Raspberry Pi is controlling the devices. Have I forgot something to say about it?
No, let's go on.
Okay. So now I will show you, because now the solar panel is not, the light doesn't shine on the solar panel. So only the fan is running.
Maybe can you switch to the dashboard?
Yes.
And I will be your assistant, if I may, right?
Okay.
So we have nice dashboard, right? And the dashboard actually showcases like what amount of watts of power are we going to get from this thing. So, you know, I would just casually like have it over here. And if everything, you know, our effort for last several months will work, we should see some spike over there. By the way, it is getting kind of hot over here next to the lamp.
The pod is started, but we don't know. We do not see it in the Grafana, but we see that the LED started or started shining. Maybe there is some problem. Okay, we have the metrics in the Grafana right now.
So that's it, right? No, I'm kidding a bit. So what we basically wanted to showcase is that you can definitely scale, like based on the, in our example, sun. The reason why we have the halogen light is that we also wanted to go much greener than this with something like a headlamp, but it has a different, what is it, frequency of light?
Yes.
I'm not sure if the frequency is correct word, sorry. But it is not able to trigger the power, the solar panel at all. So this is why we have the lamp. But so several trivia questions, because as I mentioned in the previous table, people typically don't like understand the consumption much, right? So if I would ask you, what do you think is the power consumption of this fan? What do you think? 3? Some other number? 5? Okay. It's just a half of a watt. Petr is much greener. I wanted to have much bigger thing, but this is the green one. Okay, how about these? What do you think? This should be between, I think, 1 to 5, something in between. Probably also depending on the light, right? On the color of the light that they have, right? And what about this small one? 500. Up to 500. I think, because I cannot even look at the thing, probably it's like 500. So we just want to showcase, that the devices, even though, they might look similar in size and shapes, it's kind of sometimes hard to estimate, and you really should take care of the number that is, below somewhere on the tag when you buy them, because you can still save significantly just selecting some other products or maybe having something smaller. So we apologize that we are not able to blow, up to the last corridors, but still, this is the green thing.
Okay, so if you want to see the scaling, right? We show the
Yeah, we can go on a scaling.
So you might have seen that we have the output of the USB tester, but we want to also show you the scaling in the real time. So now only the port for a fan is running, and if the David puts their solar panel, the metric gets to the Raspberry Pi, where Prometheus scrapes the endpoint or the metrics. And based on the metrics, the KEDA, the HPA scaler, scales the pod to the 1 replicas, which gives the request to the Raspberry Pi to start the LED lights. So now you can see that the pod is running, as well as the LED device. And if we take out the solar panel, it's soon start to scale down again.
Okay, can we maybe showcase also Argo CD and how does the remote cluster thing look like?
It takes some time, so yeah, it started now, and the LED is turned off.
Okay, so I just wanted to showcase how does Argo CD work with these like remote. So again, we are running Argo CD on the cluster over here. We have a second cluster on the Raspberry Pi. And if you look over here, we have factory Pi. Everything with this prefix is being run. You can see or tell it with the destination. So the destination, in fact, if you would go over here, it's other cluster that is remote. So the thing is that you would get a very, let's say, typical feeling, and from this Argo CD, you cannot even recognize that something is running afar, and you have, as an administrator, a very good, let's say, experience. Can we please also show the Kepler dashboard, just to showcase it? So Project Kepler, as we have discussed, you can imagine it basically as something similar to node exporter. So it needs to run on the machine, it is measuring. It uses the eBPF, if I may, highlight it again. And these are the results that you can have from it. So there are multiple details depending on like which zone would you like to have. You can, of course, but bear in mind that it basically is like self-sustained on a single device, and it tries to divide to ratios the power on that particular device. So basically, like having any other segmentation is, let's say, I would say questionable. This is probably one thing that is interesting. So total power consumption, and you have it for you can have it for a namespace if you like. There are much more detailed like explanations of these basic calculations, because of course you can switch some. Maybe let me start from other part. It is assuming that you are using Kubernetes in some like typical way. So for example, in a kube system, everything is like idle bundled in, and it should not be calculated differently than by ratios to other namespaces. So there are some knobs that you can maybe turn, but it's they are probably not that important.
So probably that's all for the demo. And let's get back to the presentation. Můžu? Další? Okay.
So what are some takeaways? First of all, as you have seen, being on edge is like absolutely mature. Even with the regular tooling we have, you don't need to like install anything special, work with it anything special. We are using regular Argo distribution. A K0 is again very standard-like, I would say. The power consumption is now observable, as you have the number of CPUs, memory, etc. So it's especially easy to have yet an additional dimension of your metrics, if you like. And of course, given what might await us, that we will need more power for the AI we are using, on our laptops, we probably should also think about this one. So if you are now working with cloud, what do you think is the best decision, or like, how can you help with this problem the best? Meaning, what you should do in the cloud to improve your carbon footprint? Should you go with smaller VMs? What do you think? Does it make sense? Maybe, right? If we can please have a next slide. Like, surprisingly, this is a comparison of running the same VM through the Google Cloud in multiple regions. So actually, what you can do to help is not like first thing to run smaller, this is by default, right? But to relocate to the locations that have a better ratio on the grid. So basically, if in Paris, they are able to produce more effectively with less CO2 emissions, this is the data center that you can use. And as you can see, some of those decisions are like 2 times, for example, for Europe West versus Europe West 9. So I think that a lot of us can like decide in which region to run their services. And this is yet another thing that you might consider next to the networking latency, etc. Because if you are producing just half of the CO2, well, it might make sense. If you would like to hit the planet hard, let's go to Mumbai probably. So we definitely encourage like some call to action, not just like to sit here and watch, So please try it. The thing how to do it, probably the easiest way is that you go to your cloud, and there are already dashboards in all of those major cloud providers, and you can check, how much are you consuming. They are factoring, of course, much more than the CPUs or just the VMs. Also from their other services, they do have some like ratio or estimations, and I think that you will be very surprised, how much you typically consume, or even like how much you help. So in my mind, at least, this is also about like being aware of the problem, because sometimes like making the decisions that help significantly, as you've seen, 50% cut is maybe just a different data center when we don't care. Also, one thing, except having smaller VMs, is switching to Graviton, which means ARM architecture. These are more efficient. There is a case study, if you like, to see on some like bigger scale that did happen. So that's all we had. Thank you very much.
Thank you. So I'll probably take the first one. Okay, so how much green computing do you do at work, at home or at work? Okay, honestly, I don't know because the we don't measure the green the emissions or the sustainability of the clusters. So the presentation was the first idea to start doing it.
If I may like input my take on this one, you know, previously, like a few months ago, I was working with my laptop, so I could like factor the decisions on my servers or like on my laptop. But now, you know, when I'm using AI models a lot, I think that I got like significantly worse, like 10 times worse than it was like just a few months before, unfortunately. No, but otherwise, really, if you will look even at that grid ratios, this is some first thing that you can work. We've been multiple times in a situation when we could factor this in the past, and probably we will in the future, I believe.
Okay, so the second question, yeah, the halogen lamp. I've tried. The initial idea was to trigger the solar panel by the LED lights, and it didn't work at all. So I put it to the regular sun, and of course, it worked. But then I asked why I was wondering why it doesn't work on the LED lights, and as I was advised, the LED lights have the different light frequency, which is solar panels are not used to. So the closest frequency should be the halogen lamp, and it worked. So that's the reason why we have halogen.
But we are not experts, you know, in the light spectrums. But I think that we are expert that if you have a lamp that has 500 volts and you are able to produce 1.5 on the solar panel, it's a green solution, right?
Very green, yeah. Okay, I can answer.
To be honest, up to my knowledge, I don't know. I don't know. I mean, I am not aware of any other cloud provider that would have like. What do I mean by it? If you, for example, choose ARM devices, you typically get lower price because they are cheaper to run typically by the power, but also they are probably cheaper to buy. So I'm not sure if I have seen some like different, for example, different prices. You can definitely bet that, for example, in AWS, given that each region has a different prices, this is factored in as one of the inputs. But also, you know, carbon emissions do not exactly reflect to the price, because if you would compare the price of 1 kilowatt in India and the CO2 emissions in comparison to France, I don't think that these are like much related. So maybe Europe is, you know, on the frontier of it to have some connection between these two. But I think that unless there will be some connection, that if you are just polluting, you need to pay more in some like transparent manner, probably this is not going to happen, that we would be able to get some services that are greener, maybe even cheaper. Like, I don't think that there is a connection so far. Okay, so that's all. Thank you very much.
Thank you.